Right now, as you watch this, an object from another star system is racing away from Earth at over 150,000 miles per hour. And according to Harvard astrophysicist Avi Loeb's calculations, it may have exploded into millions of pieces. But here's what makes this truly extraordinary. The physics doesn't add up. The energy calculations demand a nucleus at least 14.3 kilometers across to produce what we're seeing. Yet the Hubble Space Telescope measured it at just 1 to 2 kilometers. You can't hide 14 kilometers of ice and rock from Hubble's optics. 3I Atlas entered our detection range on July 1, 2025, spotted by Chile's Atlas Survey Telescope, humanity's third confirmed interstellar visitor in just 8 years. But unlike its predecessors, this one is breaking the rules in ways that force us to question what interstellar space actually contains. Number 10. The Blue Shift Anomaly. Comets heated by solar radiation typically glow yellowish white as dust particles scatter sunlight. 3I Atlas turned bluer as it approached the sun. Picture a snowball that becomes more metallic and shinier the closer it gets to fire. That doesn't occur in known natural processes. Number 9. The iron-nickel fingerprint. Webb's infrared detectors resolved a carbon dioxide envelope spanning 348,000 kilometers, approaching lunar orbital distance from Earth. But the spectroscopy revealed something wrong. The iron-to-nickel proportions didn't match standard cometary profiles, like a passport with correct authentication stamps arranged in the wrong sequence. Number 8. The impossible acceleration. At closest solar approach, 3I Atlas was gaining roughly 94 kilometers per day squared, already traveling beyond 150,000 miles per hour and somehow accelerating further. Forces don't materialize from nowhere in celestial mechanics. Something was pushing this object beyond what solar gravity alone could explain. Number 7. The organized jets. On November 9, 2025, British Astronomical Association observers Michael Butner and Frank Neblin photographed something that transformed the investigation. Not a diffused debris cloud from thermal breakup. They captured organized columnated jet structures. 7 distinct jets, displaying geometric patterns inconsistent with chaotic explosive fragmentation, as if material was being channeled rather than passively released. Number 6. The anti-tail formation. One jet extended 950,000 kilometers toward the sun, defying standard solar wind dynamics that push material outward. The primary outflow stretched 2.85 million kilometers in the opposing direction, approaching double Earth's distance from the sun. Debris fields from thermal stress should create randomized particle distributions. These showed structural coherence. Number 5. The sublimation crisis. From early August through perihelion on October 29th, sublimation rates escalated from 330 kilograms per second to approximately 2 million kilograms per second. That's a 6,000-fold increase. Daily mass loss shifted from sub-million-ton rates to ejecting 2 million tons per second at peak. Number 4. The energy balance paradox. Solar radiation delivered 700 joules per square meter per second to 3I Atlas at perihelion. To sublimate sufficient carbon dioxide and water ice, matching observed mass loss required at least 617 square miles of absorbing surface area. That's equivalent to a sphere 14.3 kilometers in diameter. But Hubble's July 2025 observations, captured 3 weeks post-discovery, constrained the diameter to roughly 1 to 2 kilometers maximum, a 16-fold discrepancy. Number 3. The fragmentation hypothesis. Loeb's calculations are precise. Only one mechanism reconciles the thermodynamics: catastrophic disintegration into potentially millions of smaller fragments, each presenting independent surface area. The collective thermal exposure would match energy demands. The mathematics forces this conclusion. Yet maintaining 50 billion tons monthly in sustained mass loss would require either massive intact nuclei, contradicting the fragmentation hypothesis, or millions of fragments somehow retaining extraordinary outgassing capacity. Number 2. The technological framework. If standard cometary outgassing cannot explain the organized jets, the sustained mass loss from countless small fragments, the geometric patterns, then Loeb has laid out an alternative with equal scientific rigor. Advanced propulsion systems achieve far higher exhaust velocities than sublimation processes, requiring dramatically less propellant mass to produce observed accelerations. Directional thruster arrays would create exactly the kind of columnated, geometrically organized jets November photography revealed. Number 1. The collapsing window, December 19, 2025. That's when 3I Atlas reaches closest Earth approach. Hubble and Webb are conducting intensive spectroscopic campaigns through late November and December. These observations represent humanity's only opportunity for high-resolution study. January 2026 marks the detection threshold fade. Spring passage carries it beyond Jupiter's orbit into the outer system, accelerating toward the galactic void. Miss this observational window and we'll never determine whether we witnessed remarkable natural fragmentation or encountered something the interstellar medium contains that current physics doesn't anticipate. The disintegration is real, photographed, measured, quantified. The jets are documented across multiple independent observatories. The acceleration defies pure gravitational models. What physical processes created these phenomena will define not just what 3I Atlas is, but what stories the darkness between stars has been carrying.